It's Physics 12, it's Mr. Kreitch, and it's current electricity. In the previous lessons, we talked about the three variables of Ohm's law, V, I, and R. V is voltage in volts. I is current in amps. And R is resistance in ohms. Volts are V's, amps are A's, and ohms are the Greek horseshoe, omega. Another important detail is that current in amps is really 1 amp is equal to 1 coulomb per second. So 2 amps would be 2 coulombs per second, 5 amps would be 5 coulombs per second, and so on. A coulomb is a large number of electrons. In fact, it's 6.25 times 10 to the 18 electrons. So in 1 amp you have 6.25 times 10 to the 18 coulombs, or electrons, flowing per second. And that's a lot. I just want to direct your attention to this water slide at Cultus Lake. There's two of them. The one big free fall and the one Humpty Dumpty roller coaster type of water slide too. They're side by side, so they are parallel. But if you were to think of this as being a circuit, that is one series. It's just one resistor, one drop. They might call it a voltage drop or a height drop if it's a water slide. But that would be one resistor with a big voltage drop. This would be 3 resistors, 1, 2, and 3, in series. So this is a series circuit with one big drop. This is a series circuit with 3 different drops. So this would be like a series circuit with 3 small resistors, and this would be a series circuit with one large resistor. The large resistor would have a big voltage drop or big potential loss, and this one would have 3 resistors, and each one of those resistors has a smaller potential drop. But this potential drop or voltage drop plus that voltage drop plus that voltage drop would equal this whole big voltage drop here. And now we have to see the water slide work. Here comes the big voltage drop or height drop, potential drop. There she goes. These 3 water slides are also at Cultus Lake. There's one slide here, here, and here. They all end up at the bottom into this pond, but they all came from this platform up here. You saw this in one of the previous lessons that you did. So there's one slide that comes off of here, one out here, and one off to the side. They start at the same height and end at the same elevation. So they all lose the same height. So they all have the same voltage drop or potential drop. But there are 3 slides. So although they all have the same potential drop or voltage loss, there are 3 instead of 1. So this is a parallel circuit with 1, 2, 3 resistors. Each resistor loses the same potential or voltage. One very important feature about this water slide, or these 3 water slides I should say, is if you've got just one open, the other 2 are closed down, they don't have people working on them, or they're doing maintenance on them, you'd have a big lineup of people trying to get down the one water slide, and that's a lot of resistance. That's a lot of people jammed up together. If you could open up a second one, it would be a lot easier. The lineup would go quicker. And if you opened up the third one, a lot more people would get through in the same amount of time. So if you have two resistors in parallel, you could double the current, the number of people per second. And if you had three water slides open at the same time, you could triple the number of people per second coming down the water slides. So if you could have more slides hooked up in parallel, you effectively have more current, and it's because you have less resistance of people coming down because you've got more slides open. In online lesson number 5, the one with Ohio Gulch in Hawaii, it's got a waterfall that has 1, 2, 3 drops, but it's got one up here that's just one path only. So that's a series with one drop and then another drop, and then it branches off into a parallel. Notice that all the current coming down in the first drop and the second drop breaks off into two branches which come down in this final drop here. The way I drew this is using the symbols that we have on PhET, and I just did a different version of it from PhET. This one right here, though, is the way you would actually draw it in symbols for current electricity. So it would look something like this. 7 volts. So that's how much you gain. So something had to bring the water up in the first place. In this case it's clouds, but if it was a water slide, it would be a pump that would bring the water up to the top. And at the top, we lose a little bit at one of the waterfalls. We lose a little bit more at the second waterfall, and then we lose the rest of it over 2 drops that are parallel, and it takes us right down to the bottom, and then it drifts itself back. And if instead of coming to the pond at the bottom, it got pumped back up to the top, that would be what the battery does. So we call this a 7-volt gain at the battery. And as I showed on the diagram, this one would be a 4-volt drop, or sometimes they call it potential loss or voltage loss. At the next resistor, there's a 2-volt drop or loss. And at this one right here, each one drops the final amount, so it's 1 volt each. They divide the current though, but it's that each one of them drops 1 volt. So there'd be a 1 volt drop here and a 1 volt drop here. The current is in one path only, here, 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 and then it branches off into 2. So whatever current came in here has to be what comes out at the bottom of the pond too. And that's basically the story of series and parallel. See ya. Yes, one final important detail. That diagram right here, the schematic diagram of this electric circuit, could be written this way as well. So instead of having the parallel drawn like that, it could be drawn this way. Bottom line is the same. You have a 7-volt gain at the battery, 4-volt drop at R1, 2-volt drop at R2, and then R3 and R4 both drop 1 volt. Okay, that really is it. See ya.